Hello everyone, welcome to the third episode of High School Math Fundamentals by Charles here. So we're going to get right into today factoring quadratics. Okay, so a quadratic is defined by usually defined by a polynomial with degree 2. And that polynomial, let's say it's y equals 2x squared plus 5x plus 7. The degree is 2 because the highest exponent of the variable is 2 in this case. And you'll notice it intersects the x-axis 2 times. It could also intersect the x-axis only once here, or it could not intersect the x-axis at all. And what we do when we're factoring a quadratic here is we're essentially finding the x values at which the quadratic, or the parabola, I should say, intersects the x-axis here. So, okay, so first example here, we have y equals x squared plus 9x plus 14. And the way we're going to factor this, right, we want to get it in the form, factored form, y equals x plus p, x minus q, sorry, x minus p. Where p and q are both roots of the quadratic here, or x values of the roots. Okay, so in order to do that, we are going to find two numbers, p and q, or the negative p and negative q, you'll see in a sec, that multiply to 14 here, or 14 times the coefficient of the first term, the x squared term. In this case, it's 1, so it's just 14. So we need two numbers that multiply to 14, and add to 9. Okay? So you just have to think about it for a sec and, kind of figure out in your head what two numbers satisfy these conditions. So for this case, it's 2 and 7, right? Because 2 times 7 is 14, and 2 plus 7 is 9. Okay? So we're going to split this middle term here into the 2 and 7. X squared plus 2x plus 7x plus 14, right? It doesn't matter what order you put it in. You could do 7x plus 2x. They're both the same thing. Notice how these two statements here, the x squared plus 9x plus 14 and the x squared plus 2x plus 7x plus 14, they're the exact same statement. I've just broken up this 9x term here into two different parts. So now we're gonna simplify it, and you'll see what I mean in a sec. And actually, we're gonna set this equal to 0, because when we find the roots of a parabola, on the x-axis, the y value is 0, right? So if we want to find the roots, we have to set y to be 0, right? Because remember, on the x-axis, this is the x, this is the y equals 0, all along the x-axis here, right? So let's simplify this here. We're gonna group these up actually to this x squared plus 2x, and then this 7x plus 14, right? So it's usually going to be, yeah, the first two grouped and the second two grouped. So we are going to factor out an x from this first set of brackets here. So it becomes x times x plus 2. And then from here we can factor out a 7. And that's x plus 2. Notice that when you factor, you'll have two of the same things in the parentheses here. So you can actually factor that out from the whole equation now. So you can pull out a factor of x plus 2, and what's left? x times x plus 2 over x plus 2 is just x, and then we have a 7 here. Because when you distribute this back out, you'll get back to this here. Okay. So that's it then. That's our parabola or quadratic in its factored form, right? And to actually solve for x here now, we have to say, okay, either this can be 0 or this can be 0, because 0 times something is 0, right? So we're going to say x plus 2 equals 0, or x plus 7 equals 0. We're going to move this to the other side here, subtract 2 on both sides. So x is negative 2, and here we'll do something similar, so x is equal to negative 7. Okay, and those are your solutions to this parabola up here. All right, let's do another example then. Okay, so we have another example here now. Now we need two numbers that multiply to this 10 times the 21 there, because remember it's this multiplied by the coefficient of the x squared term. So we need two numbers that multiply to 210, and we need two numbers that add to 41. Okay, so what two numbers then satisfy those two conditions? Right, this way it might be a little bit trickier, but I can just tell you that two numbers will come out to be 35 and 6. 35 times 6 is 210. 35 plus 6 is 41. Okay, so we're going to split it up again, this middle term here, and we're going to set it equal to 0. 35x plus 6x plus 21. Okay, so now we are going to group this again, and from this first bracket we can pull out a 5, because that's a common factor between the 10 and the 35, the greatest common factor. And we can pull out an x too, that's the greatest common factor, right? So what's left is 2x, because 5x multiplied by 2x is 10x squared, and we have a 7 as well. Okay, and here we can pull out a 3, and that's it. That's the common, greatest common factor between the 6x and the 21. So that's left is 2x plus 7 again. Okay, so 2x plus 7, you can factor that out of everything, and then what's left is 5x plus 3. And when you distribute this 2x plus 7 to the 5x and to the 3, you'll get back this that previous step there. Okay, so that's in our factored form. Let's say x equals now, 0 is equal to 2x plus 7, and 0 is equal to 5x plus 3. Right, so we on this first one here, so it's over, we are going to subtract 7 on both sides and then divide both sides by 2, so x is negative 7 over 2. And on this other side here, we are going to subtract 3 from both sides and then divide both sides by 5. Oops, that shouldn't be there anymore. Okay, and those are your solutions to this particular quadratic here. Okay, but what if you can't just factor it like that? Oh, and also, by the way, I should mention, if there is a greatest common factor between any of these three coefficients, you're going to want to factor that out first, just to make your life a little bit easier. It's possible to do it without factoring it out first, but it does make your life easier if you do. Okay, so let's write down another example here. Y equals negative x squared plus 7 minus, we'll do, sorry, minus 7 plus 7x, and then plus 4. Okay, so we need two numbers that multiply to negative 4 and add to 7 here. Okay, and I'm trying to think this out here. It doesn't look like that's possible. I don't think we can have two numbers here that multiply to negative 4 and add to 7. I don't think any two numbers satisfy those two conditions. So what we have to do in this case is set the thing equal to 0. And use the quadratic formula here. So our x is going to be equal to, if I remember correctly, negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so what's b, c, and a here? So if we quadratic is in the form ax squared plus bx plus c. Okay, so in this case, our a would be negative 1, our b would be 7, and our c would be 4. Okay, so now we just have to apply this formula here. Negative b, that's negative 7, plus the square root of 7 squared minus 4 times negative 1 times 4. Okay, over 2 times negative 1, and that's equal to x. Okay, so let's simplify this now. Negative 7 plus or minus the square root of 49, that's plus 16 over negative 2. Negative 7 plus or minus the square root of 49 plus 16, that is 65, square root of 65 for negative 2. Okay, so you have two solutions now. So your x could be negative 7 plus the square root of 65 over negative 2, or we can use the subtraction. And in most cases, except for some distinct word problems, both will be valid solutions. Okay, so I will compute those now. Okay, so our answers here come out to be, rounding to 2 decimal places, 0.53 and 7.53. Okay, great. So that's how you find the roots of a quadratic here, right? Thank you guys for tuning into this episode here. I hope you found it helpful. I'll see you in the next one.